the course Design and Analysis of Algorithms. Myself, I am Shravani, Assistant Professor in the Department of CSC. In today's lecture, we will cover counting sort. Basically, sorting refers to the arrangement of items either in the ascending order or descending order. And here counting refers to we have to find the frequency of the given elements in the list. So here the counting sort works basically by counting the number of elements having distinct value. Let us consider a small example. Consider an array range in between 0 to 9. This is a given array which is an unsorted list. Now first step is to count the array frequency, count the array or frequency. So here this is the index number starting from 0 to 9, which is a modified array. Here elements. So modified array elements are, so initially 0. So index 0 refers to the counting of 0 elements, okay, element zeros in the given array. Are there any elements with 0? No. So the element is 0 for index 0. Now 1. Index 1 refers to the number of ones in the given list. So how many number of ones I have? 2 ones I will be having. So 2. Now 2. How many 2's? 1 and 2. So 2's are 2. So the element is 2 under index 2. Now are there any elements with 3? No. 0. 4. Only one element. So 1. 5. One element. 1. 6. No. So 0. 7. Only one element. 1. 8. No. 0. 9. No. 0. So this is how we have to calculate the initially count array. Now I have to apply some iterations to modify this array. Okay. So here we are modifying with the previous counts. So how to modify this? Initially at index 0 I am having 0. Is there any previous index? No. So 0 initially. So this will be filled with 0. Now coming to index 1. Index 1 holds 2. So now 0 plus 2. So now 0 plus 2 refers to 2. That 2 has to be filled over here. Okay, let's see. 0 plus 2 which is equal to 2 and the 2 has to be modified. So the modified elements I am keeping in the red. So next is 2 plus 2 which is equal to 4. Now the next is 4 plus 0 which is equal to 4, which has to be filled in the index 3. Now again the next is 4 plus 1 which is equal to 5, and then 5 plus 1 which is equal to 6, 6 plus 0 which is equal to 6. Okay. Likewise we have to add them. So here 4 plus 1 which is equal to 5, and then 5 plus 1 which is equal to 6, and then 6 plus 0 which is equal to 6, and then 6 plus 1 which is equal to 7, and then 7 plus 0 which is equal to 7, and then again 7 plus 0 which is equal to 7. This is your modified array under step 2. So now we have 7 elements, 7 input elements. So we have to create an output array with the 7 empty elements. So now here this is the output array whose location is from 1 to 7, as we have 7 elements, and these are the elements we have to fill up. So for that we have to take the base as a modified array. So now we have to place the element in the correct position based on the modified count array with respect to the input array. Now whenever we are placing an element in the output array, we have to decrement the value in the modified array. So the input array and updated array are represented. Now this is your input array 1, 4, 1, 2, 7, 5, 2, and this is your modified array. Now iteration 1. So input array, the element is 1, the element visited is 1. So we have to go with the index 1. The index 1 holds a value called 2. The index 1 holds a value called 2. So we have to go to index 2. We have to go to index 2 in the resultant array, and we have to go to index 2 in the resultant array, and we have to move. We have to place this 1 to index 2 in the output array, and we have to decrement this by 1. This is what we have to perform. So let's see. So here we are visiting 1. we have 1. So, we have to go to index 1 in the modified array, and index 1 holds a value called 2. So, immediately I should go to second index in the output array, and in the second index I have to place this 1. Here I have to place this 1, and after that immediately I have to decrement this and I have to keep it as a 1. Okay, and finally this is your modified array for the next iteration. Now, what is the next element? 4. So, now I have to go with 4th index. So, in the 4th index I have 5, right? In the 4th index I have 5. So, in the 5th index of output array, I have to keep this element 4 in the 5th index. So, I have kept element 4 in the 5th index of output array, and immediately I have to decrement this 5 with 4. Decrement 5 by 1 and then it will be modified as 4. Now, what is the next element? 1. So, 1 means I should go to index 1. Index 1 holds me the value called 1. Now, I have to move to index 1, and under index 1 I have to keep the value called 1. So, here. And after that immediately I have to decrement this 1. So, decrement this 1 means 0. Now, again iteration 3. Iteration 3 means now I am at 2. So, 2 means immediately I have to go to index 2 in the modified array. Index 2 consisting of 4. So, in the 4th index of output array I have to keep this 2. So, here in the 4th index I kept 2, and after that I have to modify. Here I have to modify this 4 count with 3. Why? Because decrement. Because once I placed an element I have to decrement it by 1. Now 4 gets modified with 3. Now iteration 4. Now here I am at 7. 7 means I have to go with 7th index. 7th index holds me a value called 7. So now I have to go to 7. So now in the 7 I have to keep that value called 7. Index, say as I okay, here 5. 5 means index 5. Index 5 holds me a value called 6. Index 5 holds me a value called 6. So I should go to index 6. So under index 6 I have to place this 5. So here I placed. So immediately after placing that, here I have to decrement the 6 by 5. So now index 5 in the modified array consisting of 5. So now 2. 2 means again index 2. Index 2 holds me a value called 3. So in the index 3 of output array I have to keep this 2. So finally all the elements are filled in the output array. So finally the output array consists 1, 1, 2, 2, 4, 5, 7. This is your sorted list. This is how we have to perform the counting sort. Now worst case complexity is big O of n plus k. Now best case is omega of n plus k, average is theta of n plus k, and space complexity is big O of n plus k. N means number of elements and k is the how many number. Here we are not having any iterations like repetitions. Here we are just placing the elements just by adding, okay, only internal placements of the elements within the array. So the complexity is n plus k. Thank you. If at all if you are having any doubts, you can mail me Shravani61 @gmail.com. Thanks for watching my video. Bye bye. Have a nice day.